Okay, this video is all about solving for moles, and I wanted to include this so you guys at least have some basic understanding you can go back to and check out, see how to solve for moles. Now, a mole is two different things. Well, it's two things. A mole could be these two different things, and the first thing that you see up here is that a mole is equal to 6.02 times 10 to the 23rd. Now, they're very small things. Those are atoms, molecules, or ions. So atoms could be the sodium atom. It could be a molecule like the water molecule, or it could be ions like the iron 3 plus ion. So it doesn't matter what it is, but when we talk about moles, we're talking about things that are very small, okay? So a mole of anything, as you can see here, I did something kind of neat. A mole of anything is going to be the 6.02 times 10 to the 23rd atoms of sodium. A mole of this humongous molecule, I don't know what that is, but is also 6.02 times 10 to the 23rd. A mole of an ion is 6.02, and now if I have 2, then I'm just going to double it. So that number right there is 6.02 times 10 to the 23rd times 2. And if I have 1.8 times 10 to the 24th, that's actually 3 moles of those atoms. Okay? So a mole is equal to a number of particles. It's an extremely large number of particles, but it is that 6.02 times 10 to the 23rd number. The second thing a mole is, as you see, I'm trying to draw your attention to it here. 1 mole is also equal to the molar mass of something. I'm going to find molar mass by the numbers on the periodic table. So the numbers on the periodic table, if you look up carbon, you're going to see that carbon has 2 numbers. It either is 6, which is the atomic number, or it could be the molar mass or the mass number, which is 12.0111. So what I'm looking for is this number here. So 1 mole of carbon equaling the molar mass is going to be 12.011, and it is. So if you take a look at the moles of calcium, when I look at calcium, its molar mass on the periodic table, 40.1, and check that out on the periodic table to see that. Chlorine should be about 35.5. For iron, you'll notice that I have 2 moles of iron, so I'm going to take the molar mass of iron, which I think is not 58.5 maybe, and double it to 111.6. And if I have 81 grams of moles or something like that, and I find the molar mass of aluminum, the molar mass of aluminum you'll see is 27, so that's 3. 27 times 3 is 81. If I have 1 mole of water, then I have to take the molar mass of 2 hydrogens and add it to the molar mass of an oxygen. So the molar mass of 1 hydrogen is 1. The second hydrogen's, 1 plus 16, the molar mass of oxygen. 1 plus 1 plus 16 is 18 grams per mole. And that's my answer, right? Whoopsie. Right here. Okay? So those are the 2 things that a mole is equal to. Okay? As we move on, well, let's do that. Let's convert some of these things. Here I have 3.8 grams of copper, and I want to convert that to moles. So let me write 3.80 grams of copper. I'm going to draw a dot line. Whatever I have here has to match down here. I do that so I can eventually cancel them out. And then what I want to convert to, which is moles, always goes on top. The question is if I have blank grams of something, where do I find that? That's the periodic table. When I look up the molar mass of copper, it's 63.5. So now, since this number is on the bottom, I'm going to take 3.80, divide by 63.5, and it gives me an answer. I'm not sure what that answer is. Hold on, let me crunch it in my calculator. 3.8 divided by 63.5 gives me 0.059. 0.059. And now since I crossed off the grams of copper and I'm left with moles of copper, it's moles of Cu. That's my answer. Let's try this next one. I'm going to convert 29.4 grams of magnesium to moles. So again, whatever you have here has to go down here, grams of magnesium. Is that every time? Yes, it's every time. Now, since it's grams of magnesium, where am I going to find that number that goes there? The answer is the periodic table, and it is 24.3. So the molar mass of magnesium is 24.3. I'm looking to go to moles, so I'll put 1 mole of magnesium on top. cancel out those two, top to bottom. So again, I'm going to take 29.4 on my calculator and divide it by 24.3, and I end up with 1.21 moles of magnesium. Okay, let's try this next one. I'm going to convert 7.99 moles of sulfur, but I'm going to go to mass now. So I'm going from moles to mass. So let me do my dot line. And again, whatever you have here goes on the bottom. And you'll notice that anytime I have moles, I always put a 1 next to it. There's the 1 mole. Up here, 1 mole, 1 mole. And now, since I'm converting to mass, that goes on top. Grams of sulfur on top. And again, where do I find the mass of the molar mass of sulfur? The periodic table, and it's 28.1. I'm rounding up if you notice on the periodic table. I cross off top to bottom, but in this case, I go to my calculator. Since that number's on top, that number is 28.1, I'm going to multiply 7.99 times 28. Whoops. I'm sorry, let's start over again. 7.99 times 28.1. I end up with 224.5 grams of sulfur. Okay? Now, let's look on, see if we can get anything a little bit tougher here. Let me jump down to, okay, this is number of atoms and stuff like that. So here I have 2.5 moles of carbon, dot line. But now I want to go to number of atoms. And I know that moles is equal to molar mass, which is what I just did, and it's also equal to the number of atoms. The number of atoms, or the moles, 1 mole of anything is equal to 6.02 times 10 to the 23rd of those particles. Those could be atoms, those could be molecules, or those could be ions. Okay? So in this case, I have number of atoms. I have 2.5 moles of copper. Whatever I have here better go down here. It's always 1. And since I'm going to number of atoms, I'm going to put 6.02 times 10 to the 23rd atoms of carbon on top. So I'm paying attention to what's given to me in the problem, moles of carbon, and now I'm converting to number of atoms. So then I'm going to use the 6.02 number. And all I do is I match up top to bottom, put what I'm trying to solve on top, whoops, that's atoms, and I end up with my answer. So on my calculator, 2.5 times 6.02, don't forget to find the exponent key, times 10 to the 23rd equals 1.51 times 10 to the 24th. 1.51 times 10 to the 24th atoms of carbon. Okay, let's jump down to this one. Now I'm going to take 4.81 times 10 to the 24th atoms of silver. And I want to convert this now to moles. So atoms of silver on top, on the bottom, there. How many atoms of silver? Again, if I have this in atoms, I notice I match the numbers up. 6.02 times 10 to the 23rd. I'm converting to moles. Moles of silver. How many? So far, it's always 1. So far. I cancel out top to bottom, but now I go 4.81 exponent 24 divided by 6.02 exponent 23. I hit equals, my answer is 7.99. So again, I'm just matching top to bottom. And then from there, I match the numbers up based on the labels. Let's see if there's anything else here. Okay, let me do one of these. This is one that you'll see a lot later. If I take 412 moles of HNO3 and I want to convert that to mass, again, just follow the steps. I have moles of HNO3 here. I better write moles of HNO3 on the bottom to match it up. You always do that. How many moles? So far, it's always 1. Cancel. Then I want to go to mass. Mass is in grams. HNO3. But now in this case, I have to add up all the H's, all the N's, and all the O's. The molar mass of hydrogen is about 1 gram. I'm going to add that to the molar mass of nitrogen. That's about 14 grams per mole. And I'm going to add 16 plus 16 plus 16 because I have 3 oxygens. So 16 times 3, That's 48. So 48 plus 14 plus 1. Let's see, 48 plus 15 is 48, 58, 63 grams per mole. So I write 63 grams per mole. And that number's on top, so 412 times 63. My answer is quite large, 2.60, and I'm going to use scientific notation here, times 10 to the fourth grams of HNO3. Okay? Let me try this one right here. Converting 0.55 grams of Al2O3. All right, match them up. Grams of Al2O3 on the top, so it better go on the bottom. 1 mole of Al2O3 always on top. Now I have the task of adding up the total molar mass of Al2O3. Well, I have 2 Als and 3 oxygens, so I got to take the molar mass of aluminum, which is 27 times 2, which is 54 grams. And then I got to take 16, which is the molar mass of oxygen, times 3. That should be 48. So when I add the 2 together, 48, that's 12. And then I'm going to carry the 1. That's 102. So I take 0.55 divided by 102, gives me my final answer. And that is 0.55 divided by 102, gives me an answer of 0.00539. moles of Al2O3. Okay. Lastly, I think we have one more hard one, which is the ones that I go from atoms to mass or molecules to mass. This is the hardest one I can give you right here. Let me move it up. Okay. So what I'm going to do is take 9.71 times 10 to the 25th molecules of NH3. I'm going to convert that to mass. There's 2 ways to do this. I'm going to do it the long way. If I have molecules, the only thing I know to convert to molecules is moles. So I'm going to take 6.02 times 10 to the 23rd molecules of NH3 on the bottom and convert that to 1 mole of NH3 on top. Okay? That gets rid of my molecules. I've now been converted to moles. Now I'm going to multiply one more time, and I'm going to go from moles. Now I have moles on top up here, so I better put moles on the bottom over here. That'll allow moles on top here to cancel out with moles down here. And I need the molar mass of NH3 because I'm trying to convert to mass. So that's grams of NH3. So I got to add up a nitrogen, which is 17, and 3 hydrogens, each having a molar mass of 1. Molar mass of nitrogen is 14. 14 plus 1 plus 1 plus 1 is 17 grams per mole. So on my calculator, I will take 9.71 exponent 25 divided by 6.02 exponent 23. Hit equals. Leave the number there. Don't touch it. Then multiply by 17. Hit equals, and you end up with 2,742 grams of NH3. Let me know how this video goes for you, but that's essentially what we've done over the past couple days. It's a good tutorial. If you need anything extra, let me know, and let me know how these things work. Again, any questions, let me know. Bye.